Good morning, my YouTube viewers. It's Crystal here. I'm just here to make another video for you. This is the second time that I've made the video because I'm having some problems making videos because there's too much garble in the mic. So I'm going to make this very quickly because I have to leave for work in 10 minutes. But what we're going to do is we're going to do the F-test, which is a comparison of variances of two classes, and we've done this in a Jupyter notebook and written it in Python. So the first thing we're going to do is we're going to import numpy, which is a library that we're going to need to create numpy arrays and also compute numerical computations, and we're also going to import Seaborn so we can visualize our samples. So the first thing we're going to do is we're going to use the samples, the same samples that we have used in the last video. It's going to have 32 elements to each sample, so it's going to be class 1 and class 2. And then what we're going to do is we're going to take class 1 and class 2, we're going to convert that to a new numpy array. Then we're going to get the mean of class 1 and class 2. We're going to get the variance of class 1 and class 2. We're going to get the standard deviation of class 1 and class 2. We're going to get the length of class 1 and class 2. And then we're going to get the degree of freedom of class 1 and class 2. And I printed all that out to give you the answers, give you the computations. Now what we're going to do is we're going to compute the f-statistic, which f-stat equals var1 over var2, and your f-stat is 1.19. Then we're going to compute the p-value, and I will say that I got various answers for the p-value because one of the answers for the p-value, they didn't subtract the p-value from 1, and when they didn't subtract the p-value from 1, it gave a different answer. So I decided to use the formula for p-values that are most common. So p-value equals 1 minus stats.f.cdf, f-stat, DDOF1 and DDOF2, and that give you a p-value of 0.3. And then the next formula we have is p-value equals scipy.stats.f.sf brackets f-stat, DDOF1, DDOF2, and that also gives you a p-value of 0.3. So that's what I decided to use. Then we're going to have the f-test, and then so we created a function to perform the f-test, and the f-test gives you an f-stat of 1.19 and a p-value of 0.309. So that's the same as the values that we got at the very beginning of the video. So we know, well, we hope that's right. We're going to work on the assumption that it's right. And now what we're going to do is we're going to calculate the f-statistic for each element. And then after we have calculated the f-statistic for each element, we're going to sort it. And the thing that you have to keep in mind when you sort it is when you use np.sort, it has to say axis equals 0. If it doesn't say axis equals 0, it's not going to work because I tried it. Then we're going to calculate the PDF of the F distribution so you can see the PDF, and we're going to calculate the CDF of the F distribution. So now we're going to calculate the corresponding p-value, and that is 1 minus CDF. And now what we're going to do is we're going to visualize the PDF and the CDF using Matplotlib. So you can see Matplotlib visualizing the PDF and the CDF of the F distribution. And now what we're going to do is we're going to create a histogram using Seaborn so you can see the class 1 and class 2. So this is class 1 and this is class 2. So I had to keep this brief because I've got limited time constraints, but if you want to know what the formulas are, you can always stop the video and look at the formulas. So thank you so much for supporting my channel. Thank you for watching my video. If you like my video, please like, subscribe, and share. And I look forward to communicating with you in the next video.